Hello there. Welcome to Effective Mind Control. Think of this. You can identify one of the millions of images you have seen in just half a second. Could you have done that if such images were not stored in your memory? Could you have spotted them, without recognizing them? Where are such images stored? How are they recognized? Science lacks even a hypothesis about this mystery. But for science, combinatorial memories can be infinite. Elimination algorithms identify patterns in such memories in milliseconds. For Abraham Thomas, an engineer, intuition is such pattern recognition. Every act of the human mind results from pattern recognition. Human creativity depends on it. Human genius derives from it. Consciousness is powered by it. Fear and anger are unleashed by it. Without intuitive pattern recognition, there would be no civilization. Only stones and ice would exist today. Is intuitive pattern recognition meaningless? The algorithm explains the massive size of human memories. Intuition applies inductive logic on those infinite memories, to deliver answers to existential problems in 20 milliseconds. None of the known current research projects on human memory attempts to explain the scale and precision of human memory. This video explains the mistakes in the approach of current memory research. It begins with the intuition view that the axon helix of the 86 billion neurons in your brain can remember millions of years of your evolutionary history, along with everything you have ever done in your life. Nerve cells store these memories as working memories, episodic memories, implicit memories, and procedural memories. Those memories hold every sound, smell, image, muscle movement during your life. And, the intuition view is that there is room for infinitely more. Intuition manages such a massive memory capacity with such incredible precision. Mainstream human memory research does not provide a starting point for this capability of the mind. That is the mistake of current memory research projects. The intuition theory explains memory. Leslie Vosshall reports that, in her lab, ordinary volunteers could clearly distinguish between different combinations of 128 odor molecules, indicating an average human ability to differentiate between 1 trillion smells. These volunteers were not wine tasters or perfumers. A 2004 Nobel Prize-winning discovery pointed directly to neurons as the vehicle of memory. The memory for thousands of smells for animals resides in the combinatorial codes of their olfactory neurons. The intuition theory is that combinatorial codes in the axon helix of 86 billion neurons can virtually store an infinite memory. The most important area for memory research focuses on trivial memory feats. They study simple remembered responses in fear conditioning. In these experiments, mice and rats learn to avoid a mild electric shock to their feet, while they move around a small chamber. Once learned, animals do not forget. Placed back in the chamber, a day, or even a month later, they remember to avoid the shock. Science focuses on this simple dial 100 response. Can this response explain how the mind precisely remembers trillions of smells? No. The responses of nerve cells at synaptic junctions cannot explain memory. High-frequency stimulation of the dendrites of a neuron were known to improve the sensitivity of the synaptic nerve junctions. Such activity was seen to be remembered by the cell through greater sensitivity at specific inputs. Harvard scientists listed 117 molecules involved at the synaptic junctions which could increase such sensitivity. These chemicals assisted in linking neural paths to create increased levels of activity between neurons in different areas. Can the molecules at synaptic junctions explain the ability of the mind to precisely remember 1 of a trillion smells? No. Recently, Dr. Saktorit discovered a substance called pKMZA, which was present and activated in neighboring cells with speed dial links. The pKMZA molecules formed into precise finger-like connections among brain cells that were strengthened. The molecules remained in place to sustain the speed dial links, which enabled heightened responses to danger. However, when a drug, which interferes with pKMZA was injected directly into the brain, the animals forgot their fear. The animals even forgot a strong disgust they had developed for a taste after the administration of the drug. It was hoped that by disabling LTP, the drug could blunt painful memories and addictive urges. Can the ability of LTP to handle urgent messages help to explain how the mind precisely remembers one of a trillion smells? No. Human memory is infinitely large. People are reported to be able to recognize every one of 10,000 images shown to them at 1-second intervals. Such memories involve combinatorial arrangements of millions of pixels. Even habits require memories. The intricate movements of centipedes and horses need colossal memories. The graceful steps of a ballet dancer are learned through tedious practice. They require millions of motor memories repeating thousands of times a second. Can the dial 100 character of LTP compare with the vast potential of combinatorial memories to store astronomically large memories? No. Memory research follows many leads. One clue relates to the branched inputs of nerve cells, called dendrites. Branch growth is assisted by a protein called sipin. Some memory disabilities were related to deficits in sipin. So, one possibility was that nerve cells grew new branches to store memory. New branches could represent added memory. Growing branches to add memories also sounds perilously cancerous. But can branches grow at sufficient speeds to store 10,000 images at 1-second intervals? No. Damage to the hippocampus, a component of a region of the brain called the limbic system, is known to cause patients to forget ongoing events within a few seconds. But, incidents from childhood and early adult life were still remembered. Memory had faded from a couple of years prior to the event that caused damage to the hippocampus. Older memories were still retained by the patient even without the hippocampus. Research has identified the role of the organ in storing long-term contextual episodic memories all over the cortical regions. Can any of the known functions of the hippocampus explain how one among a trillion smells could be instantly recalled? No. The intuition theory proposes pattern recognition of combinatorial codes. Intuition is the only possible way to explain the brilliance of the human memory. Pattern recognition by neurons can practically be achieved through combinatorial codes. This process has already been acknowledged by science. The search for mathematical computations by neurons is the pursuit of a rabbit trail. The mind functions by remembering and recognizing patterns. Combinatorial codes can store human memory for both events and for habitual muscular responses. Combinatorial pattern recognition is the only practical explanation for the size and scale of human memory. Intuition justifies an infinite memory. Trust in the possible size of such a memory can help you when you recall past experiences. Thank you very much for watching this effective mind control video. When you view the brain as a pattern recognition machine, many ancient mysteries vanish. Do come back to this channel. See you next time.